A packet of baker's yeast, a spoon of sugar, 1 liter of water, 30 minutes. That's it. That is the entire input list for something that greenhouse trials measured triggering root biomass gains of up to 30% in under 72 hours. When those numbers first started circulating in gardening communities, mainstream horticulture did what it always does with anything that costs nothing and can't be sold. It called it exaggerated. It called it anecdotal. It called it the kind of thing that works in someone's backyard story, but falls apart under real measurement. Then researchers actually measured it, and the numbers held. This video is not going to tell you this works for every plant in every soil in every condition. It doesn't. But what it is going to show you is exactly what the science found, exactly how to make it, exactly what to watch for when you apply it, and exactly why something this simple and this cheap has been dismissed by the same industry that profits from selling you the alternative. Welcome to Roots Conspiracy. The garden industry has a very specific word for anything that costs nothing and can't be sold. They call it exaggerated. They called it that about yeast water too. Then the greenhouse data came back. And here is why that pattern keeps repeating. The fertilizer aisle at your garden center is not organized around what works best for your plants. It is organized around what survives the journey from factory to warehouse to store shelf to your cart. Those are two completely different design criteria, and the industry has chosen the second one every single time. Walk into any garden center and look at the fertilizer section. Dozens of products, dozens of formulations, NPK ratios, chelated micronutrients, mycorrhizal inoculants in sealed packets, slow-release polymer coatings. The messaging is consistent across all of it. Your soil is complicated, your plants have complex needs, and you need the right product, their product, to address them. Don't improvise. Don't experiment. Buy the solution. Against that backdrop, baker's yeast and sugar sounds like a folk remedy, something that belongs in the category of gardening myths alongside moon planting and talking to your tomatoes. That is exactly the category the industry wants it in. Here's what that fertilizer aisle does not tell you. The products on those shelves were not designed to maximize your plant's health. They were designed to maximize shelf life. A bag of blue crystal fertilizer can sit in a warehouse for 2 years and deliver exactly the same performance on day 730 as it did on day 1. That stability is not a feature for your plants. It is a feature for the supply chain, the living biology that actually drives root growth, the enzymes, the auxin-like compounds, the B vitamins that yeast produces during active fermentation cannot survive that journey. It has a working life measured in hours. No preservative can stop fermentation without killing the yeast. No packaging maintains biological activity across weeks of shipping and shelf time, so the industry does not sell it. And because the industry does not sell it, it does not fund research on it. And because research is not funded, mainstream horticulture has limited peer-reviewed data on it. And because peer-reviewed data is limited, experts call it exaggerated. That is a circular system that has nothing to do with whether it works. It has everything to do with whether it can be monetized. To understand why this works, you need to understand what baker's yeast actually is. Inside every packet of dry baker's yeast are millions of living cells in a dormant state, waiting for the right conditions to activate. When those cells encounter warm water and sugar, they wake up and begin consuming the sugar through fermentation. That fermentation process is not just producing carbon dioxide bubbles. It is producing a cascade of biologically active compounds that plants have been responding to for millions of years. During active fermentation, yeast cells release B vitamins, particularly B1, B6, and B12, along with amino acids and enzymes that function as direct building blocks for cellular growth. These are not synthetic versions of plant nutrients. These are the actual organic compounds that exist in living soil biology, in a form that plant root cells recognize and respond to immediately. The most significant output from yeast fermentation is a group of compounds that mimic auxins, plant hormones that function as the master switch for root cell division. When a plant root detects even trace amounts of auxin-like signals, it interprets them as a green light to begin building new root tips and branching laterally underground. This is not a slow process. In controlled greenhouse trials, researchers measuring root development in wheat and fava beans found that plants treated with diluted yeast water began showing accelerated root cell activity within an hour of application. Root dry weight gains of up to 30% were measured compared to untreated control groups. Root length increased by an average of 2.1 centimeters within 72 hours, compared to 1.6 centimeters in untreated plants. The effect is most pronounced in nutrient-poor or sandy soils, where root dry weight gains averaged 17 to 22%. In already rich, loamy soil packed with organic matter, the difference is less dramatic because the plant already has easy access to what the yeast is providing. This is not magic. This is the same biological signaling system that healthy soil microbes use to communicate with plant roots every day. The yeast is delivering those signals in concentrated form directly to the root zone, in a time frame that chemical fertilizers simply cannot match. Chemical fertilizers deliver salts. Your roots absorb those salts passively through osmosis. There is no signaling. There is no communication. There is no triggering of the plant's own internal growth systems. You are feeding the plant. You are not activating it. Yeast water activates it. If this is the kind of content you're looking for, hit subscribe. Roots Conspiracy covers practical methods backed by real data that somehow never make it into mainstream gardening advice. Now let's get into exactly how to make this. Here is the recipe that no garden center will ever put on a display. Not because it's complicated, because it's alive. What you need: 1 liter of lukewarm water, 2 tablespoons of dry baker's yeast, approximately 20 grams, 1 tablespoon of sugar. Total cost, less than $1. Water temperature is the first critical variable. Lukewarm means comfortable to the touch, around body temperature, 35 to 38 degrees Celsius. If the water is too hot, above 45 degrees, it kills the yeast cells instantly, and you have a dead brew that does nothing. If the water is too cold, the yeast stays dormant and fermentation never starts. Getting this right is the difference between a living brew and a wasted batch. Step 1. Pour 1 liter of lukewarm water into a clean container. A large glass jar or a clean plastic pitcher works well. Step 2. Sprinkle 2 tablespoons of dry baker's yeast into the water. Step 3. Add 1 tablespoon of sugar. The sugar is not for the plant. It is pure fuel for the yeast. Without it, fermentation does not start. Step 4. Stir thoroughly until both the yeast and sugar are fully dissolved. Step 5. Cover with a cloth or leave a lid slightly ajar, never sealed. Keep away from direct sunlight. Wait 30 to 40 minutes. What you are watching for? Foam. Small bubbles rising to the surface forming a visible layer of froth. This is your confirmation that the brew is alive and active. No foam means something went wrong. The yeast was too old, the water too hot, or the sugar was missing. Step 6. Dilution. This step is not optional. Add the 1 liter of fermented concentrate to 10 liters of clean water. That is a 10 to 1 dilution. This is the line between a root-boosting tonic and a recipe for burned roots. The concentrated mixture contains active compounds that, applied directly, can overwhelm young root hairs, causing wilting or stalling growth entirely. At 10 to 1 dilution, the solution is gentle enough for even the most sensitive seedlings while still delivering the full biological payload. Step 7. Apply the diluted solution directly to the base of the plant, soaking the root zone thoroughly. Do not spray the leaves. The target is the root zone exclusively. Use the solution within a few hours of brewing while the yeast is still active. Do not store it. Do not seal it in a bottle. Pressure from carbon dioxide buildup can deform plastic containers or shatter glass. Any leftover solution should be discarded, not saved for later. The reason it cannot be stored is the same reason it cannot be sold at a garden center. It is alive, and that is precisely why it works. Joe had already decided. The tomato plants were done. Late summer, heat damage, weeks of neglect, yellowed leaves, drooping stems, barely a flower left. He had mentally written them off and was going to pull them up that weekend. There was no plan to save them. There was no reason to think they could be saved. Instead, with nothing to lose, he mixed a batch of yeast water and poured it around the base of each plant. Within 72 hours, new white feeder roots were visible pushing out from the soil line. The stems firmed up. Fresh leaves began unfolding where the old ones had shriveled. Within a week, the plants were setting new flowers. By the end of the month, those same written-off tomatoes produced a flush of ripe fruit. When harvest came, Joe weighed the haul. Over 4 pounds of tomatoes from plants he had nearly composted 2 weeks earlier. That specific outcome is not guaranteed for every gardener in every condition, but the early signs Joe observed are consistent and recognizable, and they tell you exactly what to watch for in your own garden. Here is what healthy plant response looks like in the first 72 hours. At the soil surface, fine white feeder roots become visible. The plant is actively extending its root network into the area where the brew was applied. The leaves develop a noticeably deeper green as the plant begins accessing increased mineral uptake. The stem shows increased turgor. It stands straighter, firmer, with more structural integrity. In some cases, a faint sweet smell lingers around the base of the plant for 24 to 48 hours, while the yeast remains active in the soil. Signs that something went wrong are equally recognizable. If the brew was applied undiluted or at too high a concentration, root tips will brown. Leaves may wilt within 24 hours of application. The plant will look worse, not better, in the first 2 days. If this happens, flush the root zone with plain water immediately and do not reapply for at least a week. The most dramatic results consistently appear in 3 situations. Plants growing in depleted or nutrient-poor soil, fast-growing vegetable crops like tomatoes, beans, and peppers, and plants that are under stress and have already pushed their root systems as far as normal soil conditions allow. In these situations, the auxin-like signals from the yeast hit a plant that is primed and ready to respond. The root system expands rapidly. Mineral and water uptake increases measurably. The above-ground plant responds within days with visible signs of recovery and accelerated growth. Harvest data from gardeners tracking this method shows consistent patterns. Tomatoes, beans, and peppers produce heavier fruit after a single application. Yields that were averaging a handful per plant have jumped to baskets full within weeks of treatment. The proof is not just in the greenhouse numbers. It is in the way plants recover and deliver when every visible sign said they were finished. Here's the straightforward version of why this method is controversial. It cannot be sold. Not won't be sold. Cannot be sold. The moment yeast meets sugar and water, it launches into active fermentation and begins producing carbon dioxide at a steady rate. In a sealed container, that gas has nowhere to go. Plastic bottles bulge and deform. Glass bottles can shatter. Even a modest batch generates enough pressure to pop a screw cap within 24 to 48 hours. There is no stabilizer strong enough to stop fermentation without killing the yeast. No preservative that can hold back biological activity while keeping the active compounds intact. No packaging that can maintain the living biology through weeks of shipping and shelf time. So the industry cannot put it in a bottle. And if it cannot go in a bottle, it cannot generate revenue. And if it cannot generate revenue, nobody with resources is funding large-scale research on it. And if large-scale research doesn't exist, mainstream experts can credibly call the existing evidence anecdotal and exaggerated. That is the loop. It is not a conspiracy with meetings and memos. It is a structural outcome. The profit equation simply does not favor living biology. Compare this to chemical fertilizers. A sealed bag of salt-based fertilizer can sit in a warehouse for 2 years and deliver the same performance on day 730 as day 1. That stability allows for bulk manufacturing, continental shipping, and a retail model that works at scale. The entire commercial fertilizer industry is built on the fact that dead chemistry is stable and living biology is not. Shelf-stable salts are cheap to manufacture. They stack high, ship well, never spoil. When a product cannot survive the journey from factory to garden center, it never makes it to market. The most powerful living solutions are left out not because they don't work, but because they don't fit the logistics. There is also a second reason experts push back, and this one is worth taking seriously. The results are genuinely inconsistent across different conditions. In already fertile soil with high organic matter, yeast water provides minimal additional benefit. The plant already has access to everything the brew is delivering. In heavy clay soil that restricts root growth physically, no amount of biological signaling overcomes the mechanical barrier. In overwatered conditions, live yeast mixtures can contribute to mold or unwanted microbial activity in the root zone. The 30% root biomass gain that gets cited is real, but it is the high end of the range, measured in nutrient-poor sandy soil with crops that respond aggressively to auxin signals. The average gain across all soil types and plant species is lower. Some gardeners see dramatic results, others see nothing. The inconsistency is real, and it is worth knowing before you apply it. The experts who call it exaggerated are not entirely wrong about the inconsistency. They are wrong about the mechanism. The underlying biology is solid. Auxin-like compounds from yeast fermentation genuinely trigger root cell division. B vitamins and enzymes from active yeast genuinely fuel cellular growth. The greenhouse data is repeatable. What is exaggerated is the claim that it works the same way for every plant in every soil. What is not exaggerated is the biological mechanism itself. Your job as a gardener is to know the conditions where this works and apply it accordingly. Depleted soil, fast-growing vegetables, plants under stress, fresh brew every time, correct dilution, root zone application only, use within hours of brewing. Under those conditions, a $1 packet of baker's yeast and a spoon of sugar may do more for your root zone in 72 hours than anything on that fertilizer shelf has done all season. That is not an exaggeration. That is what the data says. And the reason you are only hearing it now, and not from the gardening magazine, the extension office, or the garden center display, is the same reason you heard about everything else on this channel later than you should have. There is no profitable way to sell it. So nobody told you. Here's what is actually on the record. Greenhouse trials at controlled research facilities documented root biomass gains of up to 30% in wheat and fava beans treated with diluted yeast water compared to untreated controls. Root length increased by an average of 2.1 centimeters within 72 hours. Yield data showed grain weight increases of 20 to 28% in wheat when yeast water was used as a supplement. The biological mechanism explaining these results. Auxin-like compounds triggering root cell division. B vitamins fueling cellular growth is documented in plant science literature and is not disputed. The reason this method is absent from commercial gardening products is also documented. Living fermentation cannot be stabilized for shipping and retail. The working life of an active yeast brew is measured in hours. No preservative stops fermentation without destroying the biological activity that produces the results. The fertilizer industry is built on shelf stability. Shelf stability requires dead chemistry. Dead chemistry cannot replicate the living signals that yeast water delivers to the root zone. So the industry sells what it can ship, and it calls everything it cannot ship anecdotal. Meanwhile, a packet of baker's yeast costs less than $1. The recipe takes 30 minutes. The results in the right conditions are measurable and repeatable. At some point, the question stops being whether this works, because under the right conditions it clearly does, and starts being why this conversation has been so consistently absent from every gardening magazine, extension office, and garden center you have ever seen. That is the question Roots Conspiracy keeps asking. If that conversation is worth having, subscribe and stay close. The next video goes deeper. We'll see you there.